Okay, now let's turn to continuous random variables and probabilities for continuous random variables. So a continuous random variable is a random variable that has infinitely many possibilities, not only that it has infinitely possible values, but they are uncountable. Okay, for example, how long will it take for a customer service call to be answered? Okay, well, it can take 0 or greater than 0 amount of time. Okay, instantaneously answered would be 0, but the next possible value is not 1 of anything. Okay, it cannot be 1 minute or 1 hour, because whenever if you specify a particular value, you can always do something smaller than that. And therefore, um, all we can say is the valid range. Okay, so if x is a continuous random variable, you can say what is the valid range for x. Okay. In the case of time, it has to be greater than or equal to 0. Okay. If it is something else, it may have a particular limit, okay, between 5 to 10 minutes or something like that. So here are some examples. Okay. Time between arrival of 2 consecutive customers, or the content of a cough medicine in the bottle, how many ounces are contained in the bottle. Okay, those are some examples. So the probability then is not something that is calculated with a formula. Because formula will give you one number for one value of x, but one value of x equal to 5 or 10 or whatever, is one in infinitely many possible values. So that probability will always be equal to 0. Okay, this is again a property of continuous random variables. The probability of the continuous random variable being equal to a specific particular value, like x equal to 10, that's always 0. Okay, so in continuous random variables, the probability is greater than 0 only for a range of values. So what is the probability that x is between a and b, or if x is greater than a? Those are the kinds of things that we can compute, and that is given by, okay, so we start with what is called the probability density function, or PDF. Okay, so the probability density function gives you the means from with which we can compute the probability. The area under the curve between the x-axis and the curve, that gives you the probability. So if the probability density function looks like this, then probability that x is greater than or equal to a is that area. Okay. Remember, a particular value, the probability is 0, and therefore there is no distinction between whether the equality is included in the range or not. So probability of x between a and b less than or equal to, and no, greater than or equal to a and less than or equal to b is the same as x greater than a but less than b. The equal to sign doesn't matter, because that equal to sign adds 0 probability. So if the PDF is of this type, and you want the probability of x between a and b, it is this area. Okay. Now, the probability density function which is shaped in this form is called normal distribution. Okay. So probability of x equal to a given value, remember, is always 0. Okay. Now, what are the requirements? Okay, like in basic probability, remember the 2 rules. Probability of an outcome has to be between 0 and 1, and when you sum all the probabilities for the sample space, that sum should be equal to 1. And there is a similar set of conditions for continuous distributions also, and that is the probability density function curve the curve must always be positive. Okay, so it has to be above the x-axis. Okay, there is no negative for the y-axis. X-axis can be negative, but y-axis is always on the positive side. Okay, so the function of f of x must always be on the positive side. Then the area under the curve for the valid range of x. So if x is valid between 5 and 10, then the area under the curve between 5 and 10 must be equal to 1, because that encompasses the entire possible values of x, and that probability must be equal to 1. So the total area under the curve for the valid range of the random variable must be equal to 1. So these are the two conditions that must be satisfied. And there are many continuous probability distributions out there. So we're going to look at 3 of them. Of those 3, one is very, very important to statistical analysis, and that is normal distribution. So normal distribution is something that you will see repeatedly in many different areas. So it is very important that you master how to find normal probabilities.